Hi, good day, everyone. Welcome back to class. It's learning time, so I'm welcoming every one of us to today's class. And if you are coming across this channel for the very first time, this is where we learn biochemistry in simple and plain English. So you're welcome. Please subscribe, share this video for to reach others so that they also can learn with us. And to my returning subscribers, you guys know that I love you so much. Thank you for your support. I'm really grateful. Electron transport chain. We will be looking at it in respect to photosynthesis, which is under the light phase reaction of the photosynthesis, and also our chemical pathway. But first, it helps us to transport electron until electron reach where it will be made use of. This process occurs in the inner mitochondrial membrane. Let's say this is our mitochondrial space. So now I've divided into three portions. The first place here now is the intermembrane space. This second one is the inner mitochondrial membrane, while the third space now is the mitochondrial matrix. In the inner mitochondrial membrane, we have four complexes. We have complex 1, complex 2, complex 3, complex 4. So now I know you'll be wondering that why is this one different? And also we now have the ubiquinone, and also we have the cytochrome. So we have the cytochrome A, the cytochrome B, we have the cytochrome C. So that is why I wrote here COQ. So and the CY just to maximize space. Let's go back to the name here, electron. So whatever I want to transport here is electron. So we are transporting electron. Now the question is, the electron we want to transport, where can we get these electrons from? We can get these electrons from molecules that are referred to as the electron carriers. The electron carriers, their work is just to help you to carry electron and give unto you. So example includes the NADH, we have the FADH2, and what we need from them is this that they are carrying. So now for complex 1, NADH, we come to complex 1. So when NADH comes here, NADH, it will release its electron. So NADH will now be converted to NAD plus, because we've taken what we are interested out of it, which is the electron. So now this, after releasing its electrons enters into the complex 1. So we have electron here. So the electron that enters into this complex 1 from the NADH will now make this complex 1 to be supercharged. Remember, these are taking place in the inner mitochondrial membrane. Now, in the mitochondrial matrix here, we have protons that are here. We have protons, we have them here. In this space, we have them here. How do we get these protons? Remember when your hydrogen atom breaks down, so you have your hydrogen atom, so it will now give you a proton and an electron. So the proton here are the ones here now. Then the electron gotten from here is one that enters into the complex 1. So upon the entry of this electron into complex 1, it supercharged this complex. Now remember, we said these NADH are electron carriers. In complex 1, we all now have electron acceptors. As some are carrying them, some are accepting them. So electron acceptors here in complex 1 include flavin mononucleotide, and also it includes iron sulfur center. These two are both electron acceptors. So upon the arrival of this electron into the complex 1, the electrons are taken up by the FMN and the FS center. So now, which will now help the presence of that electron inside this complex will supercharge this. When this complex is now supercharged, it will now help to pump this proton that are in the mitochondrial matrix through the inner mitochondrial membrane to the intermembrane space. So 4 protons will be pumped here. So this will help us now establish our proton gradients. Now we've make use of this one now. The next one we want to make use of is the FADH2. So the FADH2 we come to the complex 2. So we have FADH2. And remember, what we are interested in them is this and this. So we'll take which will help us to release electron also into the complex 2. So it will release electron to the complex 2. So we now have FAD. So, and you know, when it's releasing electron to the complex 2, definitely it's also giving the mitochondrial matrix protons. So, but the thing that is now different from complex 1 and complex 2, where the structures are different now, is that the presence of electron in complex 2 will not supercharge this particular complex. So the electron will remain there until further notice. It will not supercharge it. No proton will be pumped from the mitochondrial matrix to the intermembrane space. But in complex 1, electron will supercharge the complex 1, thereby causing proton pump from the mitochondrial matrix to the intermembrane space. So now, moving on now, the electron that are here now, the electron in complex 1 and complex 2 will now both enter into ubiquinon. So this one is just like, let's say, collation center. Its work is just to help us to collate this electron. Able to do that because they are lipid soluble. So the electron in complex 1 and complex 2 enters into the ubiquinon through the electron acceptors, which are the flavin mononucleotide and the iron sulfur center. You know, those are the ones that help us to accept the electron first. So the electron now from them will now carry the electron and put into the ubiquinon. So ubiquinon will now carry these electrons and pass them to complex 3. So the electrons here now will now be passed to complex 3. I hope you are following me. Now, in complex 3, what happened in complex 3? Remember I said we have cytochrome. We have cytochrome complexes. We have cytochrome. In this complex 3, we have cytochrome B and we have cytochrome C. So the electron coming from ubiquinon, when it enters into complex 3, so the place where it will stay is at cytochrome B. From cytochrome B, it will also be passed to cytochrome C. Now this complex 3 also now has electron, presence of electron now. The presence of electron here will also make this complex to be supercharged. And remember what happened when they are supercharged? They will help to pump protons from the mitochondrial matrix through the intermembrane space. So complex 3 will also help us to pump 4 protons into the intermembrane space. With that, now you see that our proton gradient is increasing. So we now have protons here. We have protons, 4 protons again here. So now the electron will now move from complex 3, where we also have this cytochrome C. So it will now move from there to complex 4. Electron now is now in complex 4. And in complex 4 also, we have cytochrome A in complex 4. So the electron that is coming from the electron in complex 3, which first enters into the cytochrome B and transfer into the cytochrome C, we now move to complex 4 and stay in the cytochrome A of complex 4. So, and also remember, since there is presence of electron here, this complex 4 will also be supercharged, and it enables you to pump proton from the mitochondrial matrix to the intermembrane space. But here it will only pump 2 proton. So in total now we have like 10 proton being pumped in complex 4. The electrons are not all also staying in complex 4. They are not. Now, the final electron acceptor in the electron transport chain is the oxygen. The electron from complex 4 will now be transferred to oxygen molecule. So, addition of electron from here with this oxygen now will lead to breakdown of this oxygen to give us 2 oxygen ion. So we have oxygen, oxygen. The electron from complex 4 will come to the final electron acceptor, which is the oxygen. So now leads to the breakdown of this oxygen to give us 2 molecules of oxygen ion. Now, 2 molecules of oxygen ion. Remember that we have protons here. We have these protons here, this hydrogen plus here. This oxygen ion here will now combine with the proton here. Oxygen ion here combine with the proton here, which will now give us H2O. Product that the product that the electron transport chain give us is water, but it also now helps us to build proton gradients, which are the proton that was transferred from the mitochondrial matrix into the intermembrane space. I hope you understand this now. This will now lead us to oxidative phosphorylation. Oxidative phosphorylation. We started with electron transport chain now, so which will now lead us to oxidative phosphorylation. What happened in this oxidative phosphorylation? What is now the fate of these proton gradients that we have here? Why is this actually important? Where are we going to get all this energy that we need that make us to pass through this process? Where are we getting them from? These and many more questions are what will be answered in the part 2 of this class. See you in the next class. Bye.